5.3 Exploring trigonometric ratios with angles greater than 90 degrees. So we have special triangles that give us the exact trig ratios for the angles of 30, 45, and 60. And these are the special triangles. You have the isosceles triangle with both the angles here being 45 degrees and 45 degrees. And the two legs are 1 unit each. The hypotenuse is square root of 2. And then you have this, which is the 30 and 60 degree angle. The hypotenuse is 2, and in the other two legs are 1 and root 3. So with that, we have learned how to find the sine of 45, the cosine of 45 and tan of 45. Similarly, the sine, cosine, and tan of 30, the sine, cosine, and tan of 60. Your textbook has the answers also in exact form as well as in rounding to 4 decimal places. But for the 45-degree angle, they have, instead of 1 over root 2, they have root 2 over 2, which is the same thing. They have just rationalized the denominator. Basically, they have taken 1 over root 2 and multiplied it by root 2 over root 2, which simplifies to root 2 over 2. Similarly, for tan of 30, the answer is root 3 over 3. And so what they did is they took 1 over root 3 and multiplied it by, root 3 over root 3. And you get root 3 over 3. So they've used just those values instead because they rationalized the denominator. But you should have this table in front of you. If you memorize it, it's good. And we're going to be using it a lot. Some new terms here. When we are looking at angles or trig ratios of angles over 90 degrees, we will be looking at their position in a grid or in a Cartesian plane. And in this case, the angle in the Cartesian plane, its vertex is at the origin, and it is an angle created between two arms. The initial arm is on the positive x-axis, and the second arm is called the terminal arm. Between the two arms, you have the angle that is being measured. So angle theta is measured from the initial arm to the terminal arm, and the terminal arm is the arm that rotates and creates the angle theta. You can also have angle theta. It's because you can see as the terminal arm moves, it's actually moving in the counterclockwise direction to create angles. But the angles created that way are positive. But if it moves in the clockwise direction, that is in this diagram here, it creates angles that are negative angles. But we will be seeing more of the positive angles that are created when the terminal arm is moving in the counterclockwise direction. We want to look at the Cartesian plane and understand it further. You have 4 quadrants, quadrant 1, 2, 3, and 4 in the Cartesian plane. You have in this diagram an angle theta that is created between the initial arm and terminal arm. As you can see, the terminal arm is in quadrant 2, creating this obtuse angle of theta. And this is an angle that is greater than 90 but less than 180 because it's sitting in the second quadrant. How would we find the trig ratios for this angle? It's not 30, 45, or 60. What we will do is we will try to find how that angle is related to the acute angle beta. So the acute angle beta is an angle between the terminal arm of an angle in the standard position and the x-axis when the terminal arm lies in quadrants 2, 3, or 4. What that means is, let me give you an example. I'm going to start off with, let's take an angle over here. Let's say we have an angle theta between the initial arm here and the terminal arm here, and this angle is 150 degrees. Okay, so it's greater than 90. This is our 0 degrees. This is our 90 degrees. This is 180 degrees. So 150 is between 90 and 180. So this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So this angle is in quadrant, you can see that the terminal arm is in quadrant 2. So what we're going to do is we're going to find what is the related acute angle here that is related to the 150. When I say that, I mean, what would this angle be in the first quadrant? So this angle here is 180 minus 150, which is 30 degrees. So this 30 is a special angle. So that helps me find the sine of 150, the cosine of 150, and the tangent of 150, because the acute angle related to 150 is 30, and I know the sine, cosine, and tangent of 30. What is the sine of 30? And what is the cosine of 30? And what is the tangent of 30? So let's go back to our table here that we have. Sine of 30 is half, cosine of 30 is root 3 over 2, tan of 30 is 1 over root 3. So I can say that for this particular case, my sine of 30 is 1 half, cosine of 30 is root 3 over 2, and tan of 30 is 1 over root 3. So my numerical answers for the sine, cosine, and tangent of 150 will be numerically equal to all of these, but they will be they may be plus or minus depending on which quadrant the angle is in. So this angle 150 is in the second quadrant where sine is positive. If you remember, there is the CAST rule, C-A-S-T. So angles that are in the first quadrant are all positive. That means A stands for sine, cosine, and tangent. All of the ratios are positive in the first quadrant. In the second quadrant, that is between 90 and 180 degrees, only sine is positive. That's why S. T stands for tangent. So angles between 180 and 270. This angle here. This angle over here is 270 degrees, right here, 270 degrees. So if an angle is between 180 and 270, it's in the third quadrant where only tan ratios are positive. And if your terminal arm ends up in the fourth quadrant, then it will be an angle where only the cosine ratios are positive. Sine and tan would be negative in this quadrant. Because 150 degrees is in the second quadrant where sine is positive, only the sine of 150 will give us a positive answer. So it will be positive 1/2. So it will be the same as sine of 30 and positive. Cosine of 150 will be the same as root 3 over 2. But because 150 is in the second quadrant where cosine is negative, cosine of 150 will be negative root 3 over 2. Tan of 30 is 1 over root 3. Tan of 150 will also be 1 over root 3, but negative because tan is negative in the second quadrant where tan is negative, only sine is positive. Okay, so we can always find the trig ratios of angles greater than 90 by finding the acute angle that is related to that angle and using the trig ratios. So in all cases, these acute angles will end up being one of the special angles. It would end up being 30, 45, or 60. And so we can use those values, like I did over here, to find the trig ratios of the larger angles or angles over 90 degrees. But pay attention to the CAST rule to know if your answers are positive or negative, like I did here. So let's say we have a special angle that is in the first quadrant is 30 degrees. If that angle is reflected in the y-axis, it ends up being the case we just saw in the previous example. This related acute angle is 30, but our actual angle theta is 150 degrees, right? If this angle is reflected in the x-axis and the y-axis, it ends up being in the third quadrant. So what is our final angle? Our angle is 180 plus 30, which is 210 degrees. So we will have the same answers for sine, cosine, and tangent. They'll be the same as sine 30, cosine 30, and tangent 30, but only tangent will be positive here, sine and cosine will be negative here. Similarly, if you perform a reflection in the x-axis of this 30 degrees, it ends up being in the fourth quadrant. And the fourth quadrant, our angle theta is 270 plus 30, which will be, so this from here to here, it's 270, sorry, it's 360 minus 30. So if you go entirely one, excuse me, just change that, I don't know what happened there. So if you go one entire revolution, you get 360. So if you move 30 degrees less than 360, you get 330 degrees. So this angle is 330 and the related acute angle is, the beta is 30 degrees. Okay. So this is just other examples of our angle. If you had an angle 150 here, then your related acute angle beta is your 30, and you're going to use the same sine, cosine, tangent of 30 to find the values of the sine, cosine, tangent in this quadrant. So let's take a look at these examples that we have here. We have the 30-60 special triangle here, and we have the reflection in the y-axis, creating an angle greater than 90 here. And then we have the same angle, but it's now in the third quadrant. They're all related to our acute angle of 30. Okay, so the 30, this is 30, this beta is 30, this beta is also 30, but the actual angle being measured in the first case here is just 30 degrees. In the second case, our angle is 180 minus 30, which is 150 degrees. And the third case here, our angle all the way from the initial arm to the terminal arm is 180 plus 30, which is 210. Okay, so if I wanted to find the sine of 30, it's 1/2, cosine of 30, it's root 3 over 2, tan of 30 is 1 over root 3. If I wanted to find the sine of 150, which is the angle from here to here, it will also be 1/2. But cosine of 150 will be negative root 3 over 2 because cosine is negative in the second quadrant. And tan of 150 would be negative 1 over root 3 because tan is also negative in the second quadrant. Now, if you have that angle 210 degrees and you're finding sine, cosine, and tangent of 210 degrees, sine of 210 would be 1/2 but negative 1/2 because sine is negative in the third quadrant. Cosine of 210 also will be negative root 3 over 2 because cosine is negative in the third quadrant. Tan of 210 will be the same as tan 30. It will be 1 over root 3. And it's in the third quadrant where tan is positive, so it stays positive. Similarly, we can also find the sine, cosine, and tangent of 330, which is the angle from here all the way till here. So it will have negative 1/2 for sine, negative 1 over root 3 for tangent, but cosine will be positive root 3 over 2 because cosine is positive in the fourth quadrant. So if we had to find the sine of 180 minus theta, so let's say an angle in the second quadrant, because 180 degrees is here. Let's say we did 180 minus an acute angle theta. It will give you the same answer as sine of that angle theta. If you did 180 cos of 180 minus theta, it will give you the same answer as cos of theta, but negative because cos is negative in the second quadrant. If you wanted to find tan of 180 minus theta, it'll be the same as minus of tan of this angle theta, but it's minus because tan is negative in the second quadrant because of cast rule. In the third quadrant, let's say you have an angle in the third quadrant, that's right here, starting at the initial arm, the terminal arm ends here. So it's an angle which is theta degrees more than 180. So sine of 180 plus theta would be minus sine theta. Cos of 180 plus theta would be minus cos theta. Tan of 180 plus theta would be plus tan theta. So it's only tan that's going to be positive, sine and cosine are going to be negative, because sine and cosine are negative in the third quadrant. And in the fourth quadrant, if you had 360 minus an acute angle theta, it would, sine of that would be minus sine theta, tan of 360 minus theta would be minus tan theta, cos of 360 minus theta would be positive cos theta, because only cos is positive in the fourth quadrant. So I want you now to try the exact value of these trig, exact values for the sine, cosine, tangent of these angles. They're all over 90 degrees. You're going to use special triangles to find the acute angle that's related to each of them, and then the cast rule to decide whether it's going to be positive or negative based on which quadrant it ends up in. So there's 4 of them. Sine 210, please copy that down. Cos 330, tan 240, sine 300, secant negative 30, and tan negative 135. Okay, so you're going to do all of these and then we will take up the answers. So I have the answers here. You can try those questions from the textbook.